Welcome back to my channel Ankura Education. Our today's topic is electronic configuration. First of all, what is meant by electronic configuration? The arrangement of electrons around the nucleus of an atom in various orbits is called as electronic configuration. Every orbit has certain capacity to accommodate the number of electrons, and the number of electrons are filled according to the Pauli's exclusion principle. That means, according to Pauli, no two elements in an electron system can have the same set of four quantum numbers. They are L, N, Ml and Ms, where L corresponds to orbital magnitude quantum number L and N is the principal quantum number, Ml is the orbital magnitude number and Ms is the electron spin. For an atom to be electrically neutral, the number of protons in an atom must be equal to the number of electrons. This denotes the atomic number of the atom. That means atomic number Z is the number of electrons revolving around the nucleus. According to Bohr atom theory, an orbit can hold a maximum number of electrons given by the formula is equal to 2n square. That means an orbit can hold 2n square number of electrons to the maximum, where n takes the values from 1, 2, 3 and so on. So, for n is equal to 1, the number of electrons is equal to 2, because n is equal to 2 into 1 square, that is 2. For n is equal to 2, the number of electrons are 2 into 2 square, which is equal to 8. That means the second orbit will hold a maximum number of 8 electrons. Similarly, the third orbit can hold a maximum number of 18 electrons. So, 2 into 3 square, which is equal to 18. All the electrons which have the same value of n in an atom are said to belong to the same electron shell. These shells are denoted by n is equal to 1, 2, 3, 4 and so on, and represented as K, L, M and N and so on. So, these shells are further subdivided into subshells corresponding to the values of L as S, P, D, G, F and so on, for L is equal to 0, 1, 2, 3 and so on. The number of electrons in a subshell is equal to 2 into 2L plus 1. So, for n is equal to 1 means it is a K shell. In that we have only one subshell, that is S. Here L is equal to 0 for n is equal to 1. So, the number of electrons is equal to 2 into L means 0 plus 1, which is equal to 2. So, the subshell S takes the number of electrons as 2. Similarly, for n is equal to 2 means it is a L shell and it has two subshells, that is S and P. N is equal to 2 means L takes the values as 0 and 1. For L is equal to 0, it is an S subshell, so number of electrons is equal to 2, and for L is equal to 1, it is a P subshell. So, the number of electrons in P subshell is equal to 2 into 1 plus 1, which is equal to 2 into 3, that is 6. So, P subshell can hold 6 number of electrons. The same process can be applied for n is equal to 3, that is M shell. In that we have 3 subshells, that is S, P and D. So, for S subshell we have number of electrons as 2, and for P we have number of electrons as 6, and for D we have number of electrons is 2 into 2 plus 1, which is equal to 10. So, this is for L is equal to 2 and L is equal to 1, L is equal to 0. So, D subshell takes the maximum of 10 number of electrons. Concept can be easily remembered with the help of this following table. So in that we have three columns, that is shell, n, L, subshell and the total number of electrons. For n is equal to 1 it is K, 2 it is L, 3 it is M and 4 it is N. So for L is equal to 0 it is S subshell, and for L is equal to 0 it is S, and for 1 it is P. For N is equal to 2. So this is as clear in this table. For L is equal to 0 S, 1 P, 2 and D. So this has continued in the next column. So the number of electrons in K shell it is 2, and in L shell, in S subshell we have 2 and in P subshell we have 6. So the total number of electrons in K shell is 8. So similarly for M shell we have 3 subshells, that is S, P and D. So there are 2 electrons in S subshell, 6 in P and 10 in D. So the total number of electrons are 18. Similarly for N subshell, N shell we have 32 number of electrons. We can write the configuration for K shell as 1s2. This is pronounced as 1s2, and for L shell it is 2s2 2p6. That means 2s2 2p6, and for third one we have 3s2 3p6 3d10, and for N shell we have 4s2 4p6 4d10 and 4f14. So this is very simple from the above table. Now let us consider one example. Say sodium, its atomic number is 11. So we have to fill these electrons according to our table. So in first orbit we can fill only 2 electrons. So 2 electrons. In second orbit we can fill 8 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. So how many electrons are completed? 1, 2, 8. So total 10. So there is only 1 electron remaining. So this is filled in the next orbit. This is called as SP, SPD levels, and this is a K shell, L shell, M shell. In that we have S, SP, SPD. So there is only one valence electron in the M shell for sodium atom. This is how we fill the electrons for an atom. Its configuration can be written as 1s2 2s2 2p6 and 3s1. This is very clear from the above representation. In the same way, we can write the electronic configurations for germanium, whose atomic number is 32, as 1s2 2s2 2p6 3s2 3p6 3d10 4s2 4p2. And for silicon, its atomic number is 14. So 1s2 2s2 2p6 3s2 3p2. The electrons will occupy the lowest quantum state first. That means the first orbit has to be filled, then the second one, and then the third one. In that also, first S shell has to be filled, and then the P shell, and again D, and after that F. This is how we write the electronic configurations of atom. So thank you for watching my video. If you like my video, please do like, share and subscribe to my channel. Thank you. If you have any doubts and suggestions, please do comment in my comment box. Thank you.